Hi, everyone, and thank you for joining us today. We're going to talk about a solution that we've built that helps you analyze text with Amazon Elasticsearch and Amazon Comprehend. I am Samir Karnik. I am the product manager on Amazon Comprehend.
My name is Ying Xiao. I'm the senior software engineer.
So, we're first going to talk about a high level overview of the solution itself. We'll talk about the capabilities of Amazon Comprehend. Ying Xiao will give you a live demo of the solution, and then we'll look into a few common use cases that we've seen that customers use the solution. This solution allows you to take unstructured data like free-form text in a natural language form and add structure to it. We've heard from customers that today they're dealing with a large amount of unstructured text. They get support communications across email, chat, social media like Facebook and Twitter, and also phone calls that can be transcribed. They also get a lot of information from their product reviews, either on review websites or on their own site through free-form text fields or other forms that they present to their customers. And then they want to keep a close eye on news articles, news that talk about product reviews, product launches, or what's generally happening in the world that affects their business and their customers as well. So this solution ingests data from sources of text such as these, uses the power of Amazon Comprehend with Amazon Elasticsearch service. The solution also comes with a pre-built Kibana dashboard, so it allows you to analyze and visualize your text. So in this case, we ran a bunch of news articles through the solution, and this is what we saw. On the top left, we see a word cloud of events. So you can see here, we see Brexit, French Open, and a few others. On the right, it's identified all the people mentioned in those news articles. So here we see Trump, James Comey, and many more people. And then on the bottom left, it identified all the places that were mentioned in the news article. So here we see Bengaluru, United States, Washington, Australia, etc. It also allows you to plot the sentiment in those documents over a time series. So on the top here, the x-axis is time, and the y-axis is a count of positive, negative, and neutral sentiments in documents. It shows you the top 10 positive sentiment documents. So in this case, I love this car, I love this movie, and so on and so forth. It also shows you the top 10 negative sentiment documents, right? So in this case, on the bottom, we can see, I hate this movie. This view is horrible. And then finally, it gives you a histogram of the count of positive, negative, and neutral sentiment documents. So here you see we had 66 positive, 54 negative, and 50 neutral. Now, before we jump into the solution itself, it's important to understand what Amazon Comprehend is and what its capabilities are. Amazon Comprehend is a fully managed natural language processing service where no machine learning experience is required. We do the heavy lifting of training data and managing models so that engineers and developers without any machine learning experience can spin up natural language processing applications very quickly. Comprehend accepts data from social media posts, emails, web pages, documents, phone transcripts, medical records, and more to help you extract key product attributes, phrases, entities, sentiment, language, syntax, and a whole lot more. So on the right, you can see it helps you extract entities like people, places, dates, events. It lets you identify the sentiment in documents, so positive, negative, or neutral. It extracts the key phrases in each document. It allows you to identify nouns, verbs, and other syntax in the language. It identifies the dominant language in a document. So currently we support 120 languages. It also helps you identify key topics for a group of documents. So common themes that are presented across a set of documents can be identified. And then one of our most popular APIs, it allows you to classify documents. So in this case, you would define your own categories and then Comprehend would classify those documents into those categories. A common use case is routing of tickets or customer contacts so that it reaches the right people in a company. So let's see how Amazon Comprehend works with this example. Here we have a couple of sentences that read, Amazon.com Inc. is located in Seattle, Washington, and was founded July 5th, 1994 by Jeff Bezos. Our customers love buying everything from books to blenders at great prices. If we run this through Amazon Comprehend, it will extract the named entity. So in this case, it found Amazon.com is an organization, Seattle, Washington is the location, July 5th, 1994 is a date, and Jeff Bezos is a person. It also allows you to extract the key phrases. So in this case, it found our customers, books, blenders, and great prices. And then it identifies the sentiment. So in this case, we said our customers love buying everything from books to blenders at great prices. So the sentiment is positive. And then, of course, it identified that the language is English. So we use this power of Amazon Comprehend in the solution that we're going to present to you today. And I'd love to hand it over to Yingxiao to walk you through the architecture and give you a live demo.
Thanks, Amir, for the introduction. Before diving deep into the demo, I would like to show you what the solution looks like architecturally, as well as the key features offered by this solution. So here is the overall architecture diagram of this solution. From this diagram, you can see there are three major components involved in this architecture. The very first one is our API gateway-based proxy API. So it exposes pre-processing configuration APIs to configure what document insights to get from Amazon Comprehend. It also exposes a full set of APIs that are fully compatible with the Elasticsearch APIs so that you can use any existing Elasticsearch SDKs such as Python, Java, or even the low-level HTTP client libraries to connect to the endpoint. The middle component is our Lambda-based proxy microservice to do the heavy lifting. So what it does is it implements the business logic to not only pass through the request to the Elasticsearch domain, but also has the business logic to get the document insights from the Comprehend. Finally, on the right, it's the Elasticsearch service domain, which acts as an index data store as well as the search engine. The key features offered by this solution includes, first of all, it has the built-in pre-processing logic to get the document insights from Comprehend. The second one is we have a pre-configured Kibana dashboard to see the visualization of the document insights. I will show you how to get access to the Kibana dashboard later in the demo. And finally, we also provide optional VPC configuration to meet the network access control requirements, as well as the identity access control for the proxy endpoints, so that every single call has to be authenticated and authorized. With that, I would like to show you how you can get started on using this solution. So the first step is to create the stack in the CloudFormation. The easiest way to do so is go to our solution webpage, and on the right side, there is a button to launch the solution in the console. So with this page has been loaded with S3 URL that contain the solution templates. I'm going to click next. In this page, I would like to walk you through some of the key parameters that you should be aware of about this solution. The first one, you are going to give a stack name. In this case, I will just type demo stack. The domain name is the name of the Elasticsearch domain. In this case, I will put a demo domain, and the rest of them are the default parameters offered by this solution, such as the instance type, instance counts. By default, the VPC is enabled, and the API gateway authorization type is the identity access control for you to authenticate the request. So by default, we choose there's no authentication is required. So the next one is a set of the VPC configurations and as well as the encryption options. So in order to, the solution also has the service row exists. And this means there's a service link row for the Elasticsearch VPC. You can check if you already have the service link row in the IAM console by searching the Elasticsearch keyword. So in many cases, if you have created the domain before with the VPC, this row will be created automatically beforehand. So in this case, we already have this row exist, so you will just choose the service row exists. So next, I'm going to go to the next page, and this is all the default stack configurations. Next, this gives you the overview of the parameters that you specify. And finally, you are going to check this box, and we can start create the stack. So the stack creation will probably take 20 to 30 minutes. I already have a stack created for you beforehand, and I would like to show you some of the key things about this stack. If you click this stack and go to the output tag, there are several attributes that will be useful in the later of the demo. The first one is the proxy endpoints. This is the endpoints that you are going to call the APIs. Second one is the Kibana dashboard URL that will help you to access our Kibana dashboard. So once the solution is created, we're going to write some code to call the APIs via our proxy endpoints. So now I'm going to show you some of the sample code to get you started. So the first API way to look at is called a create preprocessing configuration. What this API does is to instruct the solution to get what the document insights from Amazon comprehends. And I would like to show you some of the syntax of this API so that you can configure it by yourself later. So right now, I'm using a simple curl command line to make the API call. And this part is the one that we just saw in the stack outputs for the proxy endpoints. And the preprocessing configuration is the path of these APIs. And here is the body of these requests. Some of the key attributes that you should be aware of is, first of all, is the index name. When you need to index a document into the Elasticsearch domain, you have to give the index name. In this case, I just choose the name as review. While you are going to index the document into the Elasticsearch domain, you are going to provide a JSON document. And the JSON document is composed by a set of key value pairs. In this case, the field name I provide is called contents. What that means is I want to get the document insights for the value of this field name. On the right-hand side, it's an example of the documents. And as you can see, this JSON document has a key as a content, and here's a value. And I would like to get the document insights for the detect sentiments, detect entities, detect key phrases, and the detect sentiment, and the detect syntax. And the language code for this document is English. You can find other language code in our solution page. Now, I'm going to run this command to create the pre-processing configuration. All right, so it completes. So this one has been created, and we can even run a get pre-processing configuration command to see what the configuration you have right now. So here is another command to get the pre-processing configuration syntax, and it's very straightforward. You can see this is still the endpoints, and here's the path of the API, and you just need to change the verb of this request to get, and then you will get this pre-processing configuration back. So let's run this through. So this is the same configuration that we just put before. So with this configuration has been put into the service, next one, you are going to use the index API or the bulk index APIs to index a corpus of documents. In this case, I have shown you the syntax of this API. This API is fully compatible with the Elasticsearch index API. So if you have already known what the syntax looks like, it should be very trivial for you. If you haven't known this syntax yet, you can simply refer to the Elasticsearch API document for more details. So as you can see, it's a post request, and here is the endpoint again, and the review represents index name, which is the same as the index name I put there before, and you can leave _doc as it is. For the request body, it can accept any JSON documents, and in there, the content is the one that I want to get the document insights from. I'm going to run this command to show you how to index a single document into the solution. So it returned very fast. You can see the result has been created. So in the real world application, you will have already a corpus of documents in your hands, either could be in S3 or in other data storage. And you're going to iterating through all the documents by calling these APIs to index data through this solution. To get, there's another API tool called a bulk index request, which can take a corpus of documents that within one API call, which will provide a more efficient request. So this is the syntax looks like. Instead of called index, it's called _bulk. And the data binary is the one that you are going to point to the file that you are going to construct later. I will show you the file structure later in this demo. On the right-hand side, this is the syntax of this bulk request documents. Every document will composed by 2 lines. The first line is going to tell what is the index you are going to ingest. And the second one is the actual document itself. And you are going to construct as many as document you want in this document. So I'm going to run this bulk request. Okay, so I have another document to index. So as I said before, if you have a prod workload, so you are going to keep doing this index document over and over again until you finish all the documents. Okay, so this request has been finished, and here's the response of this. So the index API and the bulk index API are super useful for you to index a corpus of documents. Now, assume you have indexed the entire documents. I would like to show you how you can access the Kibana dashboard. If you go back to the solution stack outputs, you can directly click the link in the Kibana dashboard URL. So this will help you to pop up the Kibana dashboard automatically. In order to show the visualization of the document that we just indexed, you are going to the management and click the index pattern. And the review is the index I just indexed before. So you are going to click that, and You can refresh the list to populate all the properties, and you are going to start this. And now you can go back to the dashboard tab and click the review content. As you can see, there are several dashboards created as part of this. The first one is the entity dashboard. We provide 6 different entity type word cloud. So first one is the commercial items. In here, you can see the corresponding text for the commercial items such as iPhone. Similarly, we have organization entity types. We have person, location, events, and title. So the next one is our sentiment dashboard. So here is the trend of the different sentiment type over time. Here is the histogram of different sentiment types, and here is the top 10 positive and the negative sentiments. Key phrase dashboards contains 2 visualizations. One are all the word cloud of the keywords, and the second one is a heat map of all those keywords. Finally is our syntax dashboard. We visualize the verb as well as the nouns of all the document that we have indexed into. So with this, I would like to hand over the demo to Samir.
Thanks, Yingxiao. That was awesome. I'd love to talk to you guys about a few common customer use cases where we've seen this solution being really helpful. The first one is live feedback tracking. So customers can use this solution to track sentiment in survey results in real time. So let's say, for example, you're collecting feedback from customers and they're filling in survey responses in free-form text in total natural language form. You can track the sentiment from survey respondents as the feedback is rolling in. You could look at that. Information and make changes to the survey live to make sure that you're getting the most relevant responses from respondents. So let's say you're asking about feedback about product X, and all the responses are coming back about product Y. Maybe you're not asking the right question. And with this solution, you will find that out live and you'll be able to make changes on the fly. Similarly, you could track social media over a time series. So for example, you could do a keyword search on social media for hashtag Amazon. And then you could understand the keywords that are being mentioned in those social media posts with that hashtag. This way, you can track what people are saying about your product or company in real time. If the sentiment is negative with those or with that hashtag and with specific keywords, you know exactly what you need to go fix. Another example is with a new product launch. Let's say, for example, a perfume company launched a new brand called Musky Rat. You can track the social media mentions of Musky Rat and plot it on a time series. Now, with every launch, there's always some post-launch marketing activities. By looking at this time series plot, you can identify exactly which post-marketing launches were successful, which post-launch marketing activities were successful and which were not. A second common use case we see is geolocating entities. Customers can extract locations from news articles and plot it on a beautiful geolocation map in Kibana. One example of this is to understand the impact of localization. You can plot news articles and social media posts that relate to your product or organization, extract the location from those documents, and plot it on a map. Now that map will visualize where the news is coming from or the location that the news is mentioning in real time. So you can map your activities to where people are talking about it. The third common use case here is semantic search. So now you can use the abilities of Comprehend to index entities, key phrases, and sentiment for boosting and ranking search results. So not only can you do a full text search based on raw text, but you can also search for the full Comprehend document insights. So some example queries you could run are search for all documents with positive sentiment related to John Smith located in Washington, D.C. Now remember, Comprehend has already identified those entities, the locations, and the sentiment. So this search can easily be run. Another example is search for all documents that mention World Series 2019. Another example is search for all documents that mention Kindle Fire and have a negative sentiment. This could help product managers get feedback on their products in real time, make fixes on the fly, and make sure that their customers are happy. Thank you so much for joining us today. I hope you found this presentation useful. We can't wait to see what you guys can do with this solution. On this slide, you can find a few helpful links that can help you use this solution. The first link is the AWS solution overview. The second one is the solution implementation guide that has all the details that you need to run the solution. The third link is the CloudFormation template that Yingxiao used in his demo. And then finally, this is open source. So the source code is available to you as well. Thank you so much for your time.